Hi everyone, I'm Lauren Malhoit, and I'm here with our ACI 101 video series. In this particular video, we're going to talk about the Application Policy Infrastructure Controller, or the APIC, if you will. Now, every common SDN solution uses a controller, which manages the network. And in the case of ACI, we have the APIC. Now, the APIC does a lot more than just manage the ACI fabric, and we're going to get into all of that. But let's talk about what it really is physically. It's made up of a Cisco UCS C220 server. For those of you not familiar with the C-series, those are the rack mount servers, not the blades. And it actually only takes up one rack unit. However, this UCS server contains a hardened APIC image. It's not your typical UCS image, so it can't actually be managed by the UCS manager. Now, this is the only form that it's available in production today. The APIC will connect directly to two leaf switches, though you don't need to set up a virtual port channel to do this. It's just not necessary. And you'll likely have 3 or 5 APICs in your environment. And these APICs will automatically form a cluster during initial setup. Now, in the unlikely event that all of your APICs go down, you have to have at least 3 in your production environment, your fabric, your ACI fabric, will continue to run as normal. You just won't be able to create any new objects or make any policy changes during that time until the APICs are back up. Let's talk a little bit about what the APIC actually does. Now, first of all, the APIC provides an open RESTful API to the entire ACI environment. Now, this means that no matter what you want to do in ACI, you can do it programmatically or by incorporating different tools such as cloud management solutions. You can also use the GUI or the CLI to do initial configurations as well as day-to-day operations. Now, if you're familiar with the NXOS CLI already because you're using Nexus switches, then you'll be right at home here. Okay, let's get into some of the roles. Now, first of all, we use the APIC to define policy, meaning this is where we'll actually create endpoint groups, contracts, and application profiles in general. Now, the APICs also keep a complete list of all endpoints within the ACI environment. We can also check out the topology of our ACI environment from both a physical and logical perspective. There are even tools in ACI that will allow you to just print out entire network diagrams, including from a granular level, maybe at the tenant or application profile level, but also for the entire ACI environment. The APIC acts as an observer as well, so we can actually get health scores in the broad spectrum for the entire environment, as well as health scores for something like an endpoint group or a switch. Along these lines, we can also see specific faults and recommended fixes, as well as logging for troubleshooting. Finally, the APIC does some handy things along the lines of allowing us to upgrade our environment easily. It will hold various software images for both our Nexus 9K switches and the APICs themselves. We can even create what are called maintenance groups within the APIC to ensure that the fabric never goes completely down during a maintenance period. We can also set up our admins in the APIC to give read or write access to all or some of these roles. So it manages not only the overlay and underlay networks, but also gives one point of management for your virtual and physical realms. No matter if we're talking about configuring layer 4 through 7 virtual or physical appliances, or if we're talking about getting health scores for an entire tenant, no matter what it contains, this can all be done from the APIC. Now, the APIC is not actually managing endpoints. It's simply managing the policy that gets applied to those endpoints. To give you an example, the APIC isn't controlling something like vMotion or live migration, depending on if you're in a VMware or Hyper-V environment. You still need vCenter, SCVMM, or some sort of cloud management tool like OpenStack or Cloud Center for that. What it does is tell you the intent-driven policies that should apply to these endpoints, in maybe virtual machines, maybe bare metal endpoints, etc. This is actually based on promise theory. Now, you don't need to know about promise theory, so don't let that scare you away. But what this really means is that we have a model that looks like this. Say we have an admin who says, I want things to look like X. The APIC says, sure, no problem. And then in machine language, it tells the switches or the endpoint devices to do those things. The changes are then made and reported back in a feedback loop. So we also sometimes call this a declarative model, meaning the admin doesn't have to log in to each individual switch or each individual appliance in the network to configure it. They can do all of this from the APIC controller, and the APIC knows how to tell those devices what to do. Here are some references for continued learning. Thank you so much for watching, and we'll see you in the next video.